Hey everyone. I've been writing articles on Medium for about a month now on various topics like machine learning, data science, and programming. And I realized that one of the ways I can add more value to this content and make it more engaging is by converting these articles to videos. And that's what I'm going to do in this series. So, this series is just basically me converting these articles to videos so I can provide more value to the machine learning and software engineering community. So I've written around 11 articles at this point, and what I'm going to do is I'm going to convert these 11 articles to videos, and then from now on, every time I publish an article, I'll convert it to a video on the same day, and I'll publish them both at the same time. But for now, let's just go with the first article I published, which is The Beginner's Guide to the Maths Behind Machine Learning. To gain a deep understanding of how machine learning works, it's important to understand the underlying maths powering these ML algorithms. So that's what I'm going to do in this article. I'm just going to go over some of the key terminologies you need to know to understand the fundamental mathematical concepts behind machine learning. In machine learning, there are three types of maths that are powering the algorithms. So these three are linear algebra, and linear algebra defines a system for arranging numerical data and performing computations between them. So you may have heard of words like vector, matrix, and dot product. Calculus is I know it sounds a bit complicated, but it simply studies how changes in one variable affect changes in another. For example, how does a change in weather affect the number of ice cream sales? You may have heard of words like derivative, slope, and gradient, and they're all used to describe the same idea, change. Statistics refers to how data is prepared, described, and analyzed. You may have heard of terms such as standard deviation, distribution, or Gaussian. In this article, we're going to go over these terms and also kind of the fundamental concepts you need to know to understand these terms. Let's begin with linear algebra. Okay, the first topic is vectors. A vector is just a list of numbers. That's literally all it is. For example, I can use a vector to record ice cream sales for the past week. And that right there is just a vector. It's just a list of numbers. Now, given two vectors of the same shape, we can add, subtract, and multiply these vectors. So I have two vectors right here, and they each have 7 numbers in them. What we can do is we can add these two vectors together. Now, that doesn't mean just pushing them together, so squashing them together to get a vector of 14 numbers. Addition in this case means we add each element to each other, and we get the resulting vector, which is just those element-wise sums. So in the first element here, we have 11 plus 13 equals 24, 27 plus 18 equals 45, and so on. And we can do the same thing for subtraction and multiplication as well. Now, in linear algebra, we have this special operation for vectors, which is called the dot product. Now, the dot product takes two equal length vectors. Now, the dot product takes two equal length vectors, multiplies their corresponding elements, and then sums up those elements. So we have two vectors here, and when we compute the dot product between them, we'll just get a single number as a result. So what we do is we take each element and we multiply them together. So 2 times minus 3 is minus 6. Minus 1 times 7 is minus 7. 4 times 0 is 0, and 3 times 4 is 12. So we get all those products, then we add them together, and that's the dot product. Now, why is the dot product useful? Well, it's usually used for some kind of similarity computation. So if we want to understand whether two vectors are similar to each other, we use the dot product. And that's because a higher dot product means that the two vectors are more similar, and a lower dot product means the two vectors are more opposite. So in this case, we got a dot product of minus 1, which means these two vectors are pretty opposite. And that kind of makes sense because for the first element, we have a positive number, and in the second vector, the first element is a negative number. So those are opposites. Again, -1 and 7 are opposites. 4 and 0, they're not opposites, but they're not too close either. And 3 and 4, I guess they're kind of similar. So the overall similarity of these two vectors is -1, and that's the dot product. So these two vectors are not very similar. You can imagine two vectors where all the elements are positive, and when we compute the dot product between them, we'll get a pretty high number because all those dot products are positive. Even if all the numbers are negative, those two vectors are still similar because the two negatives will multiply and become a positive number. So we'll still get a pretty large dot product. Okay, the next topic is matrices. A matrix is simply a table of numbers. Okay, the next topic is matrices. A matrix is simply a table of numbers. You can think of it as taking a vector and making it horizontal, and then stacking those vectors on top of each other. Or you could take a column vector and stack it horizontally like that. Okay, so my ice cream shop is now selling 3 flavors: chocolate, strawberry, and vanilla. I can use a matrix to record ice cream sales for the past week for each of these flavors. So this first vector is the chocolate ice cream sales for the first week. The second vector is the strawberry ice cream sales for the first week. And the vanilla vector, the third row, is the vanilla ice cream sales for the past week. It's just a table of numbers. That's all a matrix is. Now, a bit of terminology. The above matrix has a shape of 3, 7 because it has 3 rows and 7 columns. And the numbers 3 and 7 are called dimensions. So a matrix has 2 dimensions because it has rows and columns. A vector has only 1 dimension because you can only go left or right or top down. And a single number is said to have 0 dimensions. Now we can add and subtract matrices of the same shape, but this operation isn't used that often in ML. The next topic is matrix multiplication. Now, this isn't the same as just taking a matrix and another matrix and multiplying the corresponding elements together. Matrix multiplication is a slightly more complicated operation, but it's actually really simple once you boil it down to what it actually does. So let's try to understand what matrix multiplication is about. So in matrix multiplication, we have 2 matrices, and the shapes of these matrices have to be in a particular format for this multiplication to work. The rules for matrix multiplication are that when we have these 2 matrices, the inner dimensions of these matrices have to be the same. So you can see that this first matrix has a shape of 2, 3, and this second matrix has a shape of 3, 4. And what's key to note is that these two, the inner dimensions, are the same. So we couldn't actually multiply the second matrix by the first matrix because the inner dimensions wouldn't be the same. We have to multiply the first matrix by the second matrix. Now, the resulting matrix is going to have the shape of the outer dimensions. So this first matrix has a shape of 2, 3. The second matrix has a shape of 3, 4. The output matrix will have a shape of 2, 4. So how is this matrix multiplication actually computed? Well, it's actually just a bunch of dot products. So let's take the first number here, 38. How do we calculate that number? What we do is we take the first row in the first matrix, and we take the first column in the second matrix. And we calculate the dot product between those two vectors, and we get that value there. So now you can see why the inner dimensions have to be the same. So for the first matrix, the inner dimension would be the column dimension. So this matrix has a shape of 2, 3, and the 3 would mean that there are 3 columns. So in this case, this vector will have 3 values because there are 3 columns. And for the second matrix, the shape is 3, 4. So the first dimension, which is 3, means that there are 3 rows. So when we extract the first column, it's going to have 3 values. And for the dot product to work, we need to have equal size vectors. And that's why the inner dimensions of these 2 matrices have to be the same. So we take the dot product of these 2 elements. You can calculate the dot product if you would like, and you'll get the result 38. Okay, let's see how we calculate this value 100. So since this value 100 is in the second row and the third column, what we do is we take the second row of the first matrix and the third column of the second matrix, calculate the dot product, and then we get the value. How do we calculate 76? Well, since 76 is in the second row and the first column, we take the second row of the first matrix and the first column of the second matrix, and we do the dot product, and we get 76. So as you can see, matrix multiplication is just a bunch of dot products. Now, matrix multiplication is important because it's the fundamental operation in deep learning, and it's basically the operation which makes deep learning possible. The next topic is transposing a matrix. So this is really easy. Transposing a matrix is just switching the rows and the columns. So if we have a matrix with shape A comma B, then transposing the matrix would make the shape B comma A. So we have this matrix right here, and we're going to transpose it, and you can see that the rows and the columns just switch. So the first row becomes the first column, the second row becomes the second column, and the third row becomes the third column. All right, that was all for linear algebra. Here I have some more resources which you can use to learn more about linear algebra, and I highly recommend going into this if you want to learn more about machine learning and you want to understand the fundamental concepts behind machine learning. In the next video, we'll continue with the same article and we'll dive more into calculus. So that will be for the next video. Thank you so much for watching. Don't forget to like and subscribe, and I'll see you in the next one. Peace.